All right, good morning, everybody. Welcome, welcome, welcome to October. We've made it, and we've been in class for a while now, since that's why we're able to say welcome to October, right? Just a reminder for everybody, we do have full classes this week, right? Whatever your schedule says or whatever you remember that you're supposed to do this week, please do it. But next week is fall break. It was fall break to coincide with what was supposed to be DCPS's all fall break, and I'm not sure if it still is, but we are on fall break next week. That means that there are no classes next week, October 12th through the 19th, something like that. Yeah, 16th, something like that. Okay, yeah. Anyway, we're off next week. Okay, so we'll be back the following week after this week. So this week, full classes. Next week, no classes. Just a reminder about that, and I'll also probably remind you on Wednesday. Okay, just so we all are on the same page about that. We're going to be working this week with ordering rational numbers. So we're continuing our conversation on rational numbers. We focused a lot on integers. And so we're now going to think about how we can apply integers to the idea of both decimals and fractions being rational numbers as well. And we're going to discuss those today. So we're going to look at rational numbers, and you guys have a pre-assessment in Schoology. So I'm going to make sure that you guys are seeing that. That should be the first thing that you guys are tackling is this pre-assessment. So let me pull up my Schoology just so everybody knows what I'm talking about. Okay, so make sure you're in Math Skills 4, the purple picture with my name. You want to be in week 4, the only red folder, comparing rational numbers. And what I would like you guys to do is the pre-assessment. So that's the second thing in the folder, but the first activity, I guess you could say, it's the little blue puzzle piece. Make sure you enter the ordering, do the ordering rational numbers. Okay, so make sure you please do that pre-assessment. As I'm here speaking, you guys should be in there now doing that. Okay, that's your goal for this morning, is to do that pre-assessment, and then we're going to move into the discussion post and the warm-up question that we have on the PowerPoint slide. Okay, so you guys can go ahead and start working on this pre-assessment. For those of you who are watching the recording later, that's what you should be doing as well. So you can pause the recording and do this pre-assessment. That's what you should focus on first and foremost, is this pre-assessment, so I can see what you guys are bringing to the table as far as your knowledge about ordering rational numbers. Remember, you do not have to be perfect on this pre-assessment. It's a pre-assessment, so if you don't know, you don't know, that's fine. But do what you can. Do not use any calculators. Only use the original calculator, this one up here, and try that. Okay. As far as announcements for this week, let me just double check. I already gave you guys the announcement about the schedule. And I don't think there's any more announcements. Always make sure to check the homeroom class on Tuesdays for the trivia. I haven't got any updates on that for this week, so I'm not sure what's going on.
I'm sorry, Mr. G.
Yeah,
Hey, how you doing? This Deontay. You said week 4, right?
yep, week 4, the only red folder.
The
Yep,
pre-assessment. I got you.
yep, exactly. Okay, and so I don't think there are any other announcements for this week other than the update to the next week's schedule, and to always check on Tuesdays for the trivia to be entered to win a gift card. I'm not running that, so I'm not sure how it works, but yes, that's the idea there. And yeah, so go ahead and just do that pre-assessment. I'm going to give you guys some time. I'm going to be quiet, let you guys do that pre-assessment. couple of you are not in the pre-assessment, so just a reminder of how to get there. You're in Math Skills 4 with my name, red folder for week 4. And then you should be doing this pre-assessment here at the top. Okay, thank you all. For those of you who are finishing up your pre-assessment, you guys can continue to do that. You guys should only have about a couple minutes left. That's fine. And if you haven't completed it yet, please make sure you do so. We're just gonna go on and discuss this problem that we have in front of us. I saw a couple people tried to answer it already. So we're gonna do this problem here in front of us. Um, okay, great. All right, so we're gonna take a taxi. Let's see, 1 second. So we're taking a taxi. It costs $3 plus an additional $2 per mile traveled. You spent exactly $20 on that taxi, which includes the dollar tip you left. How many miles did you travel? I saw a couple answers in the chat. Some people said 7, some people said 8. How do you know, and what did you do to solve it? And I think everybody's on mute. So if you're talking, you have to unmute yourself. Nobody knows? Nobody knows how to get this answer?
I'm sorry, I'm just coming back. All right, now what's going on, Mr. G?
So it was $2 times every mile. That's how I got 8. It was like 2, 4, 6, 8, 10, 12, 14, 16. After 16, you still have to count into the tip. No, the $3 to go and the dollar tip. That's how I got 8 miles because that's $4 out of everything else.
Okay, I think I heard that. You sounded kind of far away. So to recap, you're saying that you took into account the $3, which is the base, plus the dollar tip, so that's $4, right? You subtracted that from 20?
Yes.
Okay, and then you did what? What was the final step?
Uh, each mile was $1, so I did 2, 4, 6, 8, 10, like that,
Okay,
and 15,
great.
and
Okay, very good. So so $20. So yes, that's definitely one way. You should definitely take the 2 and the 4 and the 1 into account. That should be the first thing that you do, is take that $3 plus that $1, right? Because that's what it's going to cost you no matter what. That dollar tip you left plus the $3 of base fare, so that's $4. You take your 20, subtract 4, you're going to get 16, right? And then you can take that 16 and just divide it by 2 to get you 8 miles. Okay, that's how you're going to come up with the 8 miles as a response. All right, so that is the best way to do it. I did hear that you counted up, but the quicker way would be to just divide by 2 to get the 8 miles. Okay, very good. So we're going to be working with our decimals now, hence why I have this question with decimals. Money obviously has decimals. And we're going to also be taking a look at our discussion post. So let me pull that up in Schoology. Oh, don't want to, there we go. Okay, so on our Schoology page, the second thing that I have listed here is this discussion post, put the numbers in order from least to greatest. And so we have the numbers negative 1.2, negative 0.8, and negative 1.5. And let's see, a few of you have put your answers in from least to greatest. I want from the smallest to the biggest. Let's see. All right. I have one person so far that has it in the correct order from the smallest to the biggest. So what is that order from smallest to biggest? Which number is the smallest? A negative 1.2.
Negative 1.5.
Good. Negative 1.5 is our smallest number because this is the number that is furthest to the left from 0, right? I owe somebody $1.50, right? As opposed to owing them $1.20 or 80 cents. Okay, so I owe them a lot more money here. So that negative 1.5 is my smallest number. All right, so what number is next?
Negative 1.2.
Negative 1.2. Yes. So my order should be negative 1.5, then negative 1.2, then negative 0.8. All right. So remember, when we are talking about our negative numbers, the bigger the number looks in magnitude, right, is the smallest that it is because it's negative. I owe more money, right? I don't have that money, I owe it. So that is how those negatives are going to work. We have to keep that mindset alive still because we're still talking about these integers and how they work, right? So we have to think about that negative number that is smaller. Negative 1.5 is the smallest, then negative 1.2, then negative 0.8. All right, so going back to your folder, please make sure you have your notes open. We're going to do our comparing rational numbers notes. That's what we're going to work on today. Okay, are these notes? We're going to get them done for the most part, hopefully. Doing the pre-assessment, which is very important, took a lot of time from us, but we're going to use the rest of the time today to go over our notes and hopefully finish them. And so that's what we're going to work on now. So make sure you open your comparing rational numbers notes. And I have mine open already, so I will share them with you.
Hey, Mr. G, are these the notes you're talking about right here?
Yes, they should say understanding decimals. That's the first page.
I should have this paper in my folder, excuse me.
You found it? Okay.
Also, I should have this in my week 4 folder, this paper you have up?
Yeah, it should be the first assignment. It actually says comparing rational numbers notes.
Okay.
Yep. Comparing rational numbers notes. It's the 5th thing listed. 1, 2, 3, 4, 6th thing listed. Comparing rational numbers notes. Okay, and this is the first page. I don't know if you guys can hear it in the background, but there is a jackhammer going off. And it's been going off since 7:30 this morning. So I am slowly going crazy. So I apologize if I occasionally mute. It's just because I want to spare you all the noise that I'm hearing in the background, and it's driving me crazy.
Oh, no, you all right, Mr. G. They're actually building a house right next door to our house. So
okay.
I'm surprised you don't hear nothing over here.
Yeah, so yeah, so you feel my pain then, yeah, because it's super annoying.
Right.
Jackhammer won't stop. I'm like,
Right. And the thing
why
about
are you taking a break? Okay.
yeah, because I was thinking like I thought I heard background, but sorry about that interrupted. But the thing when I thought I heard something in the background, I just only thought I didn't hear anything. I didn't see
Okay.
didn't hear anything before the jackhammer.
All right. So our first part
Well, I
of today is really going to make
I get
sure that we
you can't hear
build
anybody.
the groundwork that we need to understand how decimals work, right? And I know that we have, you may have talked about decimals before, but just to make sure we're all on the same page about what a decimal is and how to relate decimals and fractions, we just want to have that baseline established, because that's the only way that we can compare them, is if we understand how they work and work together. So we had a very basic discussion the first week about what rational numbers are, right? And a rational number is anything you can write, any number that can be written as a fraction. So some decimals are rational numbers and some are not, because some of them cannot be written as a fraction, okay? If the decimal number does not stop, like it just keeps going, it can't be written as a fraction, okay? So that's an example of a decimal number that cannot be written as a fraction. But many decimals can be written as fractions, and therefore they are considered rational numbers. And rational numbers include our integers, and they also include all of our whole numbers, because we can turn any of those numbers into fractions. But a decimal and a fraction show a part of something, right? They are part of a whole. They're not a complete whole, but they are part of a whole, okay? And so what we're gonna do on this first page is really just learn how to read our decimals and how to relate them to fractions, okay? So that's really what the first part is, just establishing a little baseline. Sorry, I lost my pen, so I'm looking for that real quick. All right, it is gone, cool. All right, so understanding decimals. Let's just get into it. Okay, so the location of the number in relation to the decimal point is called the place value, right? And so if you guys don't remember place value, I did include it on this next page. There's a chart here for the place value chart, and we'll go over that in a second. But it's here too, we're gonna just talk about place value. So right after the decimal point is what place? Who knows what place that is? What is that called right after the decimal point? What do we call that place?
Be like one tenth.
It's the 10th place.
Good. It is the 10th place. And we can say that this is 3.1, right? That's a fine way to read that number. Or we can read it in the way that it's written here as this fraction, because it's going to be the same thing. It's 3 and 1/10. Okay, 3 and 1/10. Okay, so 3 and 1/10 is 3.1, right? The more mathematical way to say that number is 3 and 1/10. And then when we have the second decimal place after the decimal, the second place after the decimal, we have 3.01 or 3 and 1/100th, because that is the 100th place.
Yeah.
All right. And after that, we have 3.001, which is 3 and 1,000th, because that number is now in the thousandth place, right? And then so on and so forth. So it gets further down, right? But whatever name that we have for it as a decimal point is how you write it as a fraction. So that's why it's important to know the name and the name of that decimal place, because that's how you turn a decimal into a fraction, by making sure that you use the name of the decimal place, okay? So this one is in the 10th place, so I write it as 3 and 1/10. This one here is in the 100th place, so I write it as 3 and 100ths, all right? That is how that system works, when we are changing a decimal into a fraction. So let's do some practice with that idea. So here in this example, my example is 7/10, right? And to turn 7/10, this word into a decimal, these are the steps I would take. I would write the whole number, but there's no whole number. I'd put in the decimal point, and I did. I have a decimal point right here. Determine the place value of the decimal. Is it the tenths place, or is it the hundredths place, or whatever, right? And then write the decimal in that place. So in that case, it was just 0.7, right? Pretty straightforward, pretty simple. If I have 7/10, I make it into 0.7. If I have 11.09, an example number, like an example number 2, I still follow those same steps, but now I write down the 11 first. Then I put the decimal point after that 11. And then after I put in the decimal point, I decide what place my 9 is in. It says 9/100ths, 11 and 9/100ths. So I need to put the 9 in the hundredths place, and then I have to fill in any empty spaces with 0. All right, so that is how that's going to work. So those are the steps I would take. So now let's actually put it into practice. So how would I write 6 and 9/10? What would that look like?
6.9.
6.9, perfect. What about 2 and 8/10? What would that look like?
2.8.
Good. 15 and 15/100ths.
15.15.
Perfect.
Mr. G, I have a question about number 2.
Okay.
It
Oh,
says
sorry.
10 and 8/10. So, oh, okay.
It's just me going fast. That's all.
Yeah, I gotta say, because I didn't have that right when I put it at 10.8. That's usually.
10.8. I read it as 2 because I was going too fast. That's all. All right. Number 4, 27 and 5/1000ths.
20.
27.
Point zero.
Point 0.005
Right, 5/1000ths, right? The thousands place is
is the third place.
the third place. So that's where the 5 goes, and you just fill in the blanks with zeros.
I'm so struggling with this writing on this computer.
All
Well,
right,
that's
one.
That's the reason why I do my vote. One of my computers, one that one to let you get.
Okay, and then number 5, 1 and 300ths.
1.30.
1.03.
I
There
meant
it
03. Yeah. Thank you.
1.03.
1.03. Good. All right, and then the last one, 150 and 19/10,000ths. Oof.
150.
Uh-huh.
Point. Oh God.
Bless you.
0.
Yeah, bless you.
Bless you.
I'm
whoever-
sorry. Excuse me.
19/10,000ths. Wow, what is that? How do I even do that?
0019.
0,
0019.
19. Is that right?
There's
One more zero.
No,
Oh,
that's
it's perfect.
yeah,
Oh,
that's
okay.
right.
That's fine. Yeah, no, that's fine, but
Yeah, that's good. So we have the 10th, 100th, 1000ths, 10 thousandths. That's perfect. The 9 should be in the 10 thousandths place because that's what it says, 19 10 thousandths. So that's great. That's exactly what that should look like. Okay. Very, very good. All right. Any questions right now about decimals?
I can't write it on my board. It looks
All right,
horrible.
number 3, I'm kind of confused on number 3.
Okay. So the hundredths place, right? What place is the hundredths place? How many decimal places is that?
2.
2.
2, right? That means so the last number in this number should be in that place. So the 5 should be in the hundredths place, and it is, right?
Oh, okay.
And to make it 15, I have to put a 1 in front of it. So that's how that works, right?
Okay.
You look for the place, put that number, the last number of that number that's being said in that place, and then fill in whatever other number you need to make that work. Okay. So
Gotcha.
it's 15
Gotcha.
hundredths. That 5 needs to be in the hundreds place, and the 1 needs to be right before it. So that's how that
Gotcha.
works.
All right.
Okay. Any other questions? I know, yeah, some people say they still can't write. I understand. We'll have to try to invest in some stylus pens for you all or something. Remember, you can always use
Trying.
the text box feature in Kami to write in just the text.
Okay, so let me see if that's better.
All right. Okay, I'm going to scroll down to the next page, which is rounding, which gives us some information on how to round. Okay,
Hey,
so
Mr. G, you said I can use the text box for Kami too.
yep. So let me show that for everyone so they can all see that and how that works. So when I open up my notes in Kami, here are my notes open in Kami after all that verification it has to go through, right? And then I get down here and I need to put some information in. I use the text box on the left, and then I click it over here on the right, and I can just start answering my questions just like that, just by putting in the text box feature. So then I can just put in my notes as I go. Okay. And it automatically saves. As you can see at the top, it already said that it saves, so I don't even have to press the disk at the top. And then after I'm done filling everything in, not only do I have my notes as it saves it for me, I can also click turn in and turn it into Mr. G. All right, so yeah, the text box feature is great. Once you select it once, you don't have to select it again. Every time you click, it'll just create another text box for you to put your responses in. And that makes it neater than the drawing. The drawing, of course, will take some time to get used to, and then you can maybe do your drawing using the pen.
What's that? 10.8?
Yep, 10.8, right? 10.8.
Nah.
And this one is 27 and 5 thousandths, 0.005. Only thing that doesn't work is pressing enter. You should not press enter when you're done because it doesn't go to the next line. 150.0019. And you can always make your text boxes bigger too if that is too small. They have much bigger text boxes as well.
I can't see you, boy. What are you doing?
It's too small.
Hmm?
Okay, so rounding. How many of you feel comfortable with rounding and the idea of rounding?
Me.
Good, bad, terrible? All right, so I'm gonna give
Okay.
you some tips on rounding here. right? So when we're rounding, especially when we're talking about the decimal place, you have to find that decimal place first and look at the number after that decimal place to determine how you round, right? So determine the place to which the number is to be rounded, indicate it by circling or underlining it, and then the number to the right of that is what you're going to use to determine how you move that number, either up or keep it the same, right? If that number is 5 or higher, you go up to the next number. If that number is 4 or lower, you keep that number the same, right?
Right.
Okay. So we're going to round 2.832 to the nearest thousandth or hundredth, excuse me. So the hundredth place would be
The second
the
place
3, right?
behind the desk. Yes.
That's the thousandth place. Let me increase my zoom. I'm going to zoom in. Okay, so that's my hundredth place, excuse me, is my 3. So I have to look at my 3, right? But then I don't move the 3, right? I don't move depending on the 3. I move depending on the number after the 3, which is a 2. So this 2 here is going to tell me what to do with that 3. 2 is less than 5, so I leave the 3 alone, and I just leave it as 2.83. Right? I can write 2.830 or just 2.83. Okay, that's how we round in that first example. In the second example, which you guys can see already, I am rounding to the nearest thousandth. What number is in the thousandth place?
The number 4.
Good. This
Oh.
second 4 here is in the thousandth place. Okay, so if I'm rounding to the nearest thousandth, after that 4 is an 8, which is going to cause that 4 to become a
5.
Okay, and that's how I round up to be 43.565. Our last example, we're going to round to the nearest 100,000. So this is not even dealing with a decimal anymore. Right, the 100,000th place would be the 8, 100,000 place, not thousand. 100,000 place would be the 8. The next number after that 8 is a 9, so I need to go up to 9 to make this 5,900,000. Rounding question so far? Should be a refresher, right? Everybody's like, yeah, we did this before, Mr. G. Those y'all are very quiet though. It's okay. It's all good. All right, that's how we round. Okay. So let's compare some numbers. Now that we've done our work with establishing what decimals are, how decimals work, let's do our actual work of comparing rational numbers and comparing fractions to decimals. So I have this decimal here, 0.3, and this fraction 4/10. And I need to put them on this number line in between 0 and 1. They're both fractions of 1. So they're not quite 1, but they're bigger than 0. So how do I know which one is bigger and where to plot them on this line? How do I know which one is bigger? How do I figure that out? Which one of these is bigger?
The 3.3, the 3 is in the 10th
Place.
spot. So
Okay.
as a fraction, that would be 3/10. 3/10
what?
and
It'll be 3/10?
3/10, I'm sorry.
Yeah, oh, okay. Okay, great. So I need to, in order to compare a decimal to a fraction, right? I need to convert one or the
decimal
other,
to a fraction.
okay? So that's always gonna be my first step. If I'm comparing a decimal to a fraction, my first step is to make them both the same, either both decimals or both fractions. How do I turn a decimal into a fraction? Videra just told me, she's like, oh, it's really simple, right? We just talked about this. Hence why Mr. G put it in your brain, right? 0.3, that's the 10th place, right? So that means as a fraction, this is 3/10. So now that's gonna help me compare these two a lot easier because now I have two fractions that I'm working with. So which fraction is bigger, 3/10 or 4/10?
I'm gonna say that 4/10.
Absolutely, right?
Yeah.
4/10 is going to be a bigger fraction than 3/10, okay? And we know that because if they have the same denominator, the one with the higher numerator is the bigger fraction, right? So 4/10 is bigger than 3/10. So if I compare them, I would write it like this. 3/10 is less than 4/10. Okay, so I have that understanding down. I know this. This is a true fact. I now know that this one is smaller than that one, right? Left is smaller than the right. But now I have to figure out, how do I put them on this number line? So what do I do? How do I get them on this number line?
You can start from 0 and do fractions like 1/10, 2/10, 3/10, 4/10, and keep going until you get.
Okay, I could break this down into tenths, right?
Mhm.
Yep, that's going to be the one of the easiest ways to think about this is to just break this number line down into tenths first so that I can figure out where they go, right? That's great. That's a great suggestion, right? Doing tenths. Okay, is there another thing I can do? There's really only one other thing I think that might be slightly easier, but tenths definitely work. Is there anything else that might work? So for me, the other thing that might work is thinking about just establishing the middle of this number line, right? So if I go just to exactly in between the 0 and 1 and I find what I think is the middle, right? What is this point? What is exactly in between 0 and 1? What's in the middle of 0 and 1? What's exactly in the middle of 0 and 1?
0.
What's in the middle of 0 and 1? What's in between? What's
Half.
half of 0 and 1? I tried not to say it.
0.5?
I was trying not to say it. What's half of 0 and 1? It's just a half, right?
Yeah, half.
Right? So what's another way for me to write 1/2 if I'm thinking
5,
about
10.
10?
5/10.
5/10.
Over 10, right? So if I know where 5/10 is, I should be able to figure out where 3/10 and where 4/10 is, right? They're both to the left of that, right? And that's what's important, is just making sure that I have a general understanding of where these things should be on my number line, right? So I know that 4/10 is going to come to the left of 5/10, so I can just plot it. I'm going to use a different color, but I'm just going to plot it here. I'm going to be like, oh, right here, this is 4/10. And I know that 3/10 is less than 4/10, so it needs to come to the left of that, okay? It doesn't have to be completely accurate, right? It's spaced out perfectly, but it should be that 3/10 is less than 4/10, which are both less than the middle, 5/10, right? That just helps me establish that. If I were to do it by tenths, I just have to count 10 places and then figure out my 3 and my 4, right? But either way I can do it, and I can count where to plot my 3/4 and my 4/10, 3/10 and 4/10, all right? So whatever way works for you, but when you're trying to compare your numbers and put them on a number line, because you're going to be asked to do that, try to figure out the best way to break up your number line. So I have steps here for you, all right? And it says to figure out both of the rational numbers. I would also say in here, not just to read them, but also to convert them to the same thing, either both fractions or both decimals, and we'll go over that. And then determine how you want to break up the number line. Videra suggested tenths. The notes also suggest tenths. I love that. Break it into tenths first, and then figure out where they go in relation to each other. So let me erase this and move up my notes a little bit. Okay. All right. So it's always a good idea to figure out if you're working with two fractions or two decimals, right? So you always want to do the conversions of both, two fractions or two decimals, because you don't want to have to think one way or the other. And then decide how you're going to break up the number line. If you're going to do it into the tenths, right? Label your number line and then go ahead and plot your points, okay? So which number is going to be bigger is going to be depending on how you plot your points. So we're going to do a couple more examples like this where we are figuring out which one is bigger. In this example, we turned the decimal into a fraction. In our next example, I'm going to show you how to turn the fraction into a decimal. Okay, so in this example, we have 0.09 or 1/10. So we're working with 0.09 and 1/10 to determine which one is bigger. We're going to keep the decimal this time, and I'm going to convert this fraction into a decimal. Does anybody know how to turn a fraction into a decimal?
Wouldn't it be 0.1?
It would be 0.1. That's great. How did you figure that out?
Because it's saying 1/10, so that means that the one would be in the
Perfect.
tenths place.
So one way to do it is just by saying the fraction's name, right? You don't say 1/10, you call it by its real name, it's 1/10, and you should know that 1/10 is 0.1. If you can't remember that, the mathematical way to convert a fraction into a decimal is to divide. Divide the denominator into the numerator, right? I cannot divide 1 by 10, so I have to add a decimal and a 0. And 10 divided by 10 is just 1. So that's how I convert a fraction to a decimal, through division. I divide my numerator by my denominator and I get 0.1. So now I have these two decimals and I should be able to figure out how to compare them. Which one is bigger, 0.09 or 0.1?
.09,
0.09 is bigger than 0.1? Why?
because the 9 is in the hundredths place.
So doesn't that make it smaller?
Yes.
Oh, yes, it's smaller.
Okay, so remember when we compare our decimals, we have to compare place value to place value. Okay, so it doesn't matter that that 9 is a bigger number than that 1 because all we care about is the place value, right? So we don't even see what's over here on this side. All we see is that 1 is bigger than 0, and this is enough for this number to be bigger than that number, okay? We have to compare place value to place value when we compare our decimals, all right? So that 9, nobody cares about that 9 yet. We haven't gotten to that 9. We're still at the 10th place, and in the 10th place, that 1 is bigger than that 0. So 0.09 is less than 0.1. Okay, so I've established that 0.1 is greater than 0.09. Now, how do I put this on my number line? This number line goes from 0 to 0.5. So what am I working with here? Did somebody say something? What? What? Huh?
Oh, man.
You got to
I
speak
didn't
up.
hear the question. What was the question, Mr. G?
How do I plot this? How do I put this on my number line? And now I'm working with a vertical number line instead of horizontal. It's now vertical, straight up and down. How do I
Right.
put this information on this number line?
Can't you do 0.1, 0.2 and keep going up?
Okay, so 0.1 would be where? Down here?
Yes.
Okay. So I would just pick down here to be 0.1. Does that work?
Yeah, that works.
Okay, and then I go, and then this is 0.2, 0.3, 0.4, 0. Okay, it's gonna go up. Okay, so where
Yeah,
does
it's gonna keep going up until you get
0.09
to
go?
0.09.
Where does that go?
Doesn't
said
that go before the 0.1?
Aha,
Oh, yeah, 0.9 should go before because it's less than.
right. So it should go right next to it, right? 0.09. They're very close, right? They're very close in value. 0.09 and 0.1, they're very close in value. So that should go right about there. But both of them should be closer to 0 than to 0.5, right? 0.5, halfway between 0 and 0.5 would be 0.25, somewhere over here. So remember that 0.1 and 0.09 are going to be closer together in value. You too, Ebony. All right. Okay. So even if you're working with a vertical number line versus a horizontal number line, what you always have to establish is where you're going to be, how and where you're going to be plotting your numbers, right? We're always going to be working with, mostly going to be working with horizontal number lines and not vertical ones. But just the idea is that, remember, if you're starting from 0 being the bottom and the lowest, recognize that, and then recognize where your end point is. What is the highest point in that graph, okay? Or in that number line. That's 0.5. And then make your adjustments accordingly. Okay, so 0.1 is greater than 0.09.
So is that 0.25 or is that 0.15?
That's 0.25, that's halfway. Let me adjust my writing because I have a critic today. Everybody's a critic. 0.25, yes. Everybody is a critic, it's okay, it's fine. I'll take all the critiques I can get.
Nah, I'm not a critic like Rolling Stones.
All right, let's try this next piece. Let me clear these drawings. Okay.
We getting through a lot of this. Let's see.
All right, so we have now it's a little bit harder, right? Now we're gonna get into the real, now that we've seen how it works in a really easy fashion, we have 0.65 and we have 3/5. All right, this is, now we can't use our naming as much. We can't just go from one point to the other to figure out which one is bigger and which one is smaller, right? This one, it takes a little bit more work. So what are we going to do here? We have 0.65 and we have 3/5. My question to you is, are we going to make them both decimals? Or are we going to make them both fractions to compare them? We're obviously going to do both, but I want to know which one you want to start with. Are we going to make them both decimals or both fractions?
Decimals.
We're going to start with decimals. Okay. So that means we're going to keep the 0.65. We're going to turn 3/5 into a fraction. How do we turn 3/5 into a decimal? Excuse me. How do we turn 3/5, this fraction, into a decimal? What do I have to do?
3/5 into a decimal.
How do I do that?
Divide 5 by 3.
Divide 3 by 5. Right?
Okay.
Divide your numerator by your denominator. So 5 is on the outside, 3 is on the inside. Right? And of course, 3 is smaller than 5. So I cannot divide.
You have to put a decimal point and add a 0.
Add a decimal and a 0. How do I divide 30 by 5? How many times does 5 go into 30?
6.
6 times. So as a decimal, this fraction 3/5 is actually 0.6.
6.
Okay, so now I can compare my two decimals, right? I have 0.65 and I have 0.6. Which one is bigger?
And 0.6.
Which one is bigger?
It's 0.65.
0.65.
Zero
I mean, I'm
point
sorry,
six.
0.6. Yeah, 0.6.
What?
No, 0.65 is bigger.
Yeah, that's what I
Remember,
But
said.
I thought if you add a z, see what I'm
we
thinking about
compare
is adding a
place.
zero.
We compare place value to place value, right? Okay,
Mhm.
so let's start with just the zeros. The zeros have the same value, so we don't know which one is bigger, right? Then we
Right.
go to the 6s. They have the same value. We don't know which one is bigger, but then we get here. We have 5 or 0. Which number is bigger?
Okay.
This number is bigger. All right. Always compare place value to place value. These are the same. These are the same. And then we have 5 or we have nothing. Which one is bigger, 5 or nothing?
But
5.
see, what's confusing to me, Mr. G, is how we was doing the number line, right?
Yep.
Like 0.60, that would be farther to the right versus 0.65, right?
Nope. Let's put it on a number line. Let me see. Do I have a number line next? Is my next thing a number line? No. Okay, so let's go back and let's put it on a number line. Okay, so we have, so the question is 0.6 and 0.65, right? So again, we're going to find the middle of this number line. We're going to call it 0.5, right? And let's say in between 0.5 and 0. What's halfway in between a half and a dollar, or 50 cents and a dollar? What's halfway in between 50 cents and a dollar?
25.
You said what's halfway between what?
50 cents and a dollar.
75 cents.
Okay. Do you see it yet? Do you see it yet, Madera? Do you see it yet? No? Okay. So if I have 0.75 here and 0.5 here, right? I'm going to have 60 cents here and 65 cents here, right?
All right.
Right?
Mm-hmm. Mm-hmm.
Yes?
I'm listening.
So if I have 0.6 here, this is more to the left than 0.65, which is more to the right. This has a value that's closer to 1
Right.
than 0.6, right?
They do.
I
So
have,
basically 0.6 is 60 cents. 0.65.
right. This is 60.
Right. I mean, I know that as far as sets wise, but it just confused me as far as
On
the
a
number line thing. Yeah.
Right. So, but on the number line, 0.6 is going to be closer to 0 than it is to 1 compared to 65, right? Because 65 needs to be to the right, right? Because anytime you add a number after that initial decimal, right, you are adding more value. It's not a
I
lot
have a
of value.
question.
It's not a lot of value, but it's more value.
Okay, got you.
Right.
I have a question.
So if I have 0.6 and I have 0.6001, that's still more than 0.6. Even if it's 0.001, even if it's so far away, right? But that 1 still has more value than a bunch of zeros following that 6, all right? Somebody else had a question. Go ahead.
Yes, I have a question. So, how can you tell the difference between 60 cents and 6 cents? Like, what? That I think that's where I be getting confused with the decimals.
Is that 6 or 60?
So that's 6 cents. It will be a 0 in front of that.
Is that 6 or 60?
That's 60 cents.
Is that 6 or 60?
That's 60.
Is that 6 or 60?
That's 60.
Okay. These two are 60 cents. This one is 6 cents. What's the difference?
There's a zero
Aha.
in front of, but in behind the decimal.
So there's a 0 before
Yeah.
the 6, right? But behind the
Right.
decimal, that's what makes that 6 cents. In order to
Okay.
be 60 cents, I need to have a 6 immediately after the decimal. So this is 60 cents, or with the 0, it's still 60. These are the same, this is the same number. It doesn't matter that I put a 0 here and not a 0 here. It's both 60 cents. What changes is when I put a 0 right after my decimal, right? That means I no longer have any dimes, right? I only have pennies.
Okay.
So here is the value that gives me a tenth of a dollar, so a dime, right? And this value only gives me pennies. This is my pennies value.
Look at you.
Pennies versus dimes is what we're looking at here. So the first decimal is for dimes, and the second decimal is for pennies, if that helps with the distinction, right? Because this is
It does. It does.
that's tenths, and this is hundreds.
It does. It just gets confusing sometimes when you're putting it on a number line. When you have some of those questions that's asking you questions like that,
Yep.
and you're comparing and contrasting, or you're doing equal to, that's one way you could get tricked up. So I just wanted to get the specific.
No, this is good. This is a good question. All of these kinds of questions is how we learn, guys, right? Like if these are the times to ask the questions, because you don't want to see the question on the CASAS test, get it wrong on the CASAS test, and be like, Mr. G, I got this wrong. What was I supposed to do? No, that's not the time to ask me. You ask me now so that you don't get it wrong on the CASAS test, right? So no, this is great. I love these questions. All right, anything else I need to clarify about the 60 versus 65? No? You sure? Okay,
No, that helped to make it clear.
good. All right. We'll see how clear it is as we keep going. I don't know.
It's still gonna be a blur to me till I figure it out on my own, even after all of what you just said.
All right, let me put this back in. So 3/5 as a decimal is 0.6. That's what we were just doing. We converted the 3/5 by doing 5 into 3. We added a decimal and a 0. All right, 5 goes into 36 times. 5 times 6 is 30, right? So it's just 0.6, and that's how we got that decimal, okay? All right, so we've compared our two decimals, and we know that 0.65 is greater than 0.6, all right? How do we change this decimal into a fraction? That's the next thing we need to do. How do we turn a decimal into a fraction?
Ooh.
Is it 65 over 100?
Why did you say it so
65
quietly?
yeah,
Why did you say it
65 over
so
Because I'm
100.
not sure.
You were saying it, and then as you got closer to the end, you got quieter and quieter. Is it 65 over
100.
Yeah, I think that's right, because the 5 is in the hundreds place.
That's perfect.
Oh, okay. All right.
You use the place value of the number, right? Or you use the name of the decimal. It's not 0.65, which is fine. We can say 0.65. We're all used to saying that. That's how we read those numbers, right? But if we read them more mathematically, we have 65 hundredths. So that's what we write, 65 over 100, okay? And then we have to reduce that fraction. What does it mean to reduce the fraction?
Find its lowest.
Find its lowest terms. So divide it, right, by numbers that both the numerator and the denominator are divisible by. In this
Right.
case,
That's where I have a problem at.
yes, and I know most people do, don't worry. So when we're looking at divisibility rules or how to divide two numbers, if they end in 5 and 0, there's only one number that
10.
to both 5
5.
and 0, not 10.
Okay.
Number. If it ends in 5, if one number ends in 5 and the other number ends in 0, there's only one number that you can use to divide both numbers by. What number is that?
5.
5.
5. Oh,
5
okay.
is the only number that can go into numbers that end in both 5 and 0. Any number
my
that ends in
God.
5 and any number that ends in 0 is divisible by 5.
You just made that 100%
So
easier.
that's 13 over
Okay, so how many times does 5 go into 65?
13.
It goes in 13 times. Very good. And how many times does 5 go into 100?
20.
20 times. Perfect. So the
That look like-
fraction of 0.65 is 13 over 20. All right. So I'm going to erase everything in blue. I'm going to leave the red there. I just need to erase the blue so I can have space to show you now how to compare two fractions. Okay. When I'm comparing decimals, it's really easy and straightforward, right? I just compare place value to place value. And then that's how I compare them. When I compare fractions, it requires a little bit more work, but it's not that challenging. You just have to give yourself the time and the space to get used to it, okay? So I have 13 over 20 and 3 over 5. In order to compare them, you have to cross multiply, okay? And you go from the bottom to the top when you cross multiply, always from the bottom to the top. So I'm going to go from 20 and multiply it to 3. What's 20 times 3? What's 2 times 3?
6.
So then I just add a 0, right? 20 times 3 is the same
60.
as 2 times 3 with a 0 at the end, right?
Mhm.
20 times 3
Mhm.
is 60, all right? And what's 5 times 13?
20. I'm
25.
sorry.
35.
65.
Oh, it's 60.
65.
Oh, yeah,
Kind of
it
a
is
trick
because 5
question
then
'cause
you
we
1.
just
So,
did.
yeah.
Okay, so the number on the left is the value of the fraction on the left. The number on the right is the value of the fraction on the right. Which number is bigger?
65.
65 is bigger than 60, right? That means 13 over 20 is greater than 3 over 5. We already knew that because we already knew that this number, 0.65, was bigger than 0.6, right? But that's how you compare your fractions. You cross multiply always from the bottom to the top, right? And that's how we cross multiply. And then we use the values of that multiplication to determine which fraction is bigger and which fraction is smaller. Okay, so I'm going to show that to you again, just using a random example of 2 different fractions, just so you guys know it always works. Because you're like, oh, it works here, but we just saw that it works in another way, so I'm not sure that it works. I know what you're talking about, Mr. G. Trust me, I've done this before, so I know this reaction. I've definitely had this reaction before. Okay, so which one of these 2 fractions are bigger? 7 over 9 or 2 over 3? Which one's bigger?
I
Nobody
think
knows?
it's 2 over 3, I think.
Nobody knows just off the top of their head? What? It's okay.
So
We're going to use
I was gonna
cross
say 7 over 9.
multiplication.
7 over 9, but
So what's 9 times 2?
9 times 2 is 18.
18. What's 3 times 7?
21.
21.
21. So which fraction is bigger?
7 over 9.
7 over 9 is bigger. That's how we compare our fractions. Okay?
Oh,
Cross
shit. I got it.
multiplication to compare them. So 21 is bigger than 18. 7 over 9 is bigger than 2 over 3.
Hey, again,
You
can you
cross them off.
explain? I forgot which side is what. How you?
Yep.
Yeah.
So this is why we go from bottom to top, right? So I'll show you again. Let's say I have 3/5 and well, let's just 2/3 again. Why not? And 2/3. Okay. I always go from the bottom, right, of one side to the top of the other side, right? It's important to do it that way because that's how I determine the value of the leftmost fraction, to go from the bottom of the right up to the left. So what's 3 times 3?
Nah.
9. Okay, and now I do the other bottom to top. So 5 times 2, what's 5 times 2?
10.
10. So the value on the right is for the fraction on the right. The value on the left is for the fraction on the left. Which number is bigger, 10 or 9?
10.
10.
So 2/3, right, is greater than 3/5.
So you gotta bottom to the top, but you gotta come from the right
So
side
that's
first.
how you be getting that. You cross multiply.
It doesn't matter which, it doesn't matter if I go left or right first, but always bottom to top. That's
Okay.
what's important, right? If I do 5 times 2, I'm still gonna get 10. The problem is that if I do 2 times 5, I'm gonna get 10. I'm gonna put this number on the left. And it's not
Yeah,
for the
that's
left
what I'm saying.
fraction, it's for the
Yeah.
right. That's why you must do bottom to top. It doesn't matter which bottom to top, but it must be bottom to top.
Okay.
Because if I do top to bottom, I'm gonna put the 10 on the wrong side. That's why. All right, one more example. Let's do 3/4. And
All right, so when you cross multiply, you do from bottom to top, not top to bottom.
always bottom to top. Yes,
Okay, I got you. Okay.
always bottom to top. All right, so in this case,
I used to think it was top to bottom.
I'm gonna go 4 times 4, which is what?
16.
16. 7 times
21.
3, which is what?
21.
So which fraction is bigger?
21.
3/4.
3/4.
Yep, so 3/4 is greater than 4/7.
7.
Okay,
Thank you, Mr. G, because that makes a lot of sense.
yep. And that's the easiest way to compare your fractions. And I think a lot of people will be like prefer to compare decimals to decimals, but when they see how easy it is to compare fractions, they kind of switch up. They're like, oh, I could just cross multiply, right? But remember, you always have to cross multiply
From the
to
bottom.
top.
The bottom up.
All right. Okay, we're gonna go back to our notes. Already forgot where I was. Okay, so we compared these two fractions already. You guys should have these notes in here for them, but I'll add them back in as well. Right, so this fraction is 13/20. This decimal is 0.6. Okay. And so we now know how to convert back and forth, right, between a decimal to a fraction to a decimal. And let's see, was there anything else I needed to show you guys here? Right, good. We showed that, I did that. Showed how to compare them. Perfect. Okay, so we're gonna do this example here, and then we're gonna call it a day. So we tried it already once with the 0.65 and whatever. So now we have 0.25 and we have 6/10. So again, we're only going to compare them once. We're either going to compare them both as decimals or both as fractions. So what do we want to do?
Want to compare them both.
As fractions? Both as fractions?
Yeah.
I heard that first. Is that okay?
Fractions.
Yeah.
Mhm.
Okay, we're going to make them both in the fractions. So we have to take the 0.25 and make it into a fraction. How do we do that?
25
over 100.
Over 100.
Very good. So it's 25 over 100. Okay, but now I have to reduce it and make it as simple as possible. So what do I do?
Divide by 5.
Okay, I could divide by 5. That's good. I can divide by 5. I'm going to be dividing by 5 a lot, though, if I do by 5s.
Right.
Because I have
Take a
25.
zero.
20. Yeah, you can do 25.
Well, because 25 goes into 100, right? Because we have quarters, right? We have
Yeah.
quarters.
Yeah.
We should know that 25 goes into
That'd be
100.
1/3.
So we just do 25 into 25, we get 1. And then 25 into 100 gives us
4.
So it's 1/4. So we have 1/4 as our fraction, and then we have 6/10 as our other fraction. So how do we compare them?
All right, so we do quad multiplying from multiplying. So for
Okay, good. So what do we do?
So 6. So you start with 4. 4 times 6. 4 times 6. That give you 24.
Very good. And then
Start and then 10 times 1 will be 10. So
good. So which fraction is bigger?
6 cents.
6 over.
So 1/4 is less than 6/10. Or you can say, instead of 1/4, you can use the original. You can say 0.25 is less than 6/10, right? Either way is fine. Okay, so we obviously did not finish our notes today. We still have 2 pages left of notes. So we'll finish them on Wednesday in class. So you guys don't have to do any additional work today to get full credit for today, as long as your pre-assessment is done and your response to the discussion question, the discussion post is done. If those 2 things are done, you guys are good for the rest of the day. Even if you're watching the video back, that's all the work that needs to be turned in today for full attendance. On Wednesday, we will complete the notes and we'll go over the practices for the week. Does that sound good? Any questions?
Yeah. I just got one thing. I know how we usually come into class and we normally have to put our name into the chat box, and I didn't do that. So will we still have to do that to make sure that we're actually present, or you'll take care of all that?
So it's only important for the record keeping purposes for the people who are over us, right? For OSSE, for people who are in the district, in case somebody ever questions, well, you said Deontay was present, but I don't see his name in it. Like that's really all that's for, is to make sure you have a double check. Like all they really have to do is watch the video to see that you were in class, right? But sometimes they want to make it easier for themselves, so they need that check, and that's the only reason that's there for. I put attendance in based on who is in class, right? I don't even check the chat, right? But that chat is just that's just for record keeping. So don't worry about it. It's like if you weren't here early enough to put your name in, or you haven't, or you forgot, it's not for me to give you attendance. It's for them when they're doing a check later.
Okay.
Okay.
Yes, sir. I'm fine. I'm done. Everything that you said that we had to do to make sure that we was good for the rest of the day, to make sure we was attending.
Yeah,
I did it while we was online. So
perfect. That's great. That's what I'm looking for. All right. So I'll see the rest of you on Wednesday then. If anybody else has any questions, you can ask me. But if not, I will see everybody on Wednesday.
No, I appreciate that, Mr. G. That was a nice class.
Hold on, Mr. G.
Yep.
Can we save the work that we was doing just now on Kami, or
it automatically saves?
Yeah.
So you don't have to do anything.
It automatically does that.
Exit.
It does at the same time.
So once we exit out, it'll automatically
come back up. Yep.
Right, but it does that to me too. It does that to me the first time when it's telling me that I have to retard. I had to retard for some reason, but then it just come back.
So yeah, anything that I've put in. So I put in all that text up here in the first part. Let's see. Yeah. So when I exit it, I'm just gonna click the exit. You'll watch, you guys. You can watch so you can see what happens. I'm gonna clear my desktop as well. When I open it again, all of my notes that I recorded actually on camera, because the rest of this I just wrote over it using my screen, but you can see everything that I wrote in is actually still there.
Yeah, and it's still there.
Okay, thank you.
Yep. All right, y'all. I will see everybody on Wednesday.